Being fat is not a health risk per se. It's a somewhat inconvenient truth. There are many seriously overweight people who are perfectly healthy. I put the perfectly in inverted commas. If you are seriously heavy, you are putting strain on your joints and things. So you aren't untouched by the additional weight, but you're not a heart attack waiting to happen. Likewise, there are lots of people who are normal weight, walking around with serious metabolic issues. The catch all term to describe these people is their insulin resistance. Now, insulin resistance is a rather broad term, subject to different interpretations. At the end of the day, people who are insulin resistant are not short of insulin. They're awash in the stuff. In fact, insulin levels are high morning, noon, and night. And this is where the metabolic troubles begin. So, what makes someone insulin resistant? Well, it can't be fat per se. Join us for this episode of Better Body Chemistry TV as we probe what is the difference between healthy fat people and unhealthy fat people. Understanding what goes wrong is key to tackling the metabolic fallout, which is compromising the health of millions of people. Better Body Chemistry TV is brought to you by Dr. Sandy, a scientist turned gremlin buster, helping you battle sugar gremlins, heifer lumps, and other health horribles through better body chemistry. Remember, small things can make a big difference to your health. In search of an answer, a team of researchers from Finland took advantage of a rather rare biological phenomenon. Sets of identical twins that are not the same weight. Yep, it happens. One twin is fat and the other is thin. Same genes, same lifestyle growing up, different body composition. So, what did they find? Well, let's just make it clear. Finding these individuals was not easy. They scoured twin databases containing over 5,000 sets of identical twins, ending up with 15 sets of twins who differed from each other by at least 3 BMI points. So yes, genes are big when it comes to body composition, but they are not everything. The team did a comprehensive assessment of each twin's metabolic status and then pinched a few fat cells to look at under the microscope. Ouch. The fat sample came from just under the belly button, relatively close to the surface. So the fat cells being investigated were subcutaneous fat cells. Now, these are generally considered the good guys. Yes, just like cholesterol, there are good fat cells and bad fat cells. I know, if you're overweight, you see them as all bad. But the ones associated with metabolic problems are the visceral fat cells. These ones are located deep inside the abdominal cavity. Getting hold of these is problematic. Think invasive surgery. So, in this study, the team is looking at the goings on in subcutaneous fat cells. Now, as expected, the fat cells in the fat twin were fuller than in the thin twin. Nothing exceptional here. But when it came to fat cell numbers, in the fat twin, two distinct patterns emerged. It was close to a 50-50 split. In 7 cases, the fat twin had more fat cells than the thin twin. And in 8 cases, the fat twin had less fat cells than the thin twin. Less fat cells in the fat twin? Yes, you heard that correctly. The person was fatter, but with less fat cells. Translated, this means that the fat cells were seriously full, and it turned out that this mattered. The team identified the group with less fat cells as the group having hypoplasia. Hypo in medical speak always means too little. The group with more fat cells were classified as having hyperplasia. Hyper meaning many. Here you can see the metabolic consequences of having too few fat cells. The insulin sensitivity is compromised. This is reflected by the HOMA score. Fasting insulin levels shoot up from 5.9 to 9 milliunits per liter. With insulin levels in the stratosphere, metabolic chaos ensues. The liver is jammed with fat. Cholesterol is higher, and there is a low-grade inflammation. Fat cells behave differently. When the team looked at what was actually going on inside the fat cells by looking at gene expression patterns, they found that the biology of fat cells was a little different from thinner fat cells, which probably isn't that surprising. In a word, fat cells were less insulin sensitive. So what does this mean? Well, we're warring against fat cells, campaigning for their elimination. But maybe they are the good guys. They're working hard to protect us from our dietary indiscretions. When they fail, we slide into metabolic disease. At this stage, we don't have a clue as to why the number of fat cells doesn't expand to meet the demand for extra fat cells. If you've got metabolic troubles, the best you can do is help those full to capacity fat cells get their groove back by draining them a little and changing their biology so they become less insulin resistant. Need some help? Download our free report, which introduces you to the candy floss system and the 10 different biological weapons you can deploy to help you combat insulin resistance so you create better body chemistry and better health. Interested in discovering more ways to create better body chemistry, or need a little help getting your body chemistry on track? visit our website at www.betterbodychemistry.com. Browse our library or enroll in one of our courses or programs. The advice is simple to follow and based on real science, not hype. Know someone who hates their fat cells? Share this video with them so they realize that health problems happen when those misaligned fat cells fail. And if you enjoyed the video, be sure to subscribe to our channel so you catch future episodes of Better Body Chemistry TV. Thank you so much for watching, and I'll see you next time. Remember, small things can make a big difference to your health.